A'udhu billahi minash shaitani rajim. Bismillahir Rahmanir Rahim. In Unit 9, we will discuss the fundamental concept of modulation, which is the part of Chapter 2 and the course Introduction to Communication System 8022305. In the previous unit, we explored and discussed the electromagnetic spectrum in Unit 8. Now we are going to discuss another topic such as concept of amplitude modulation technique, which is the heart of modern communication system. Modulation is the process of varying one or more characteristic of a high frequency carrier signal in accordance with the instantaneous value of another signal known as the modulating or message signal. The signal that carries the actual information to be transmitted is called the modulating signal, message signal, or baseband signal. Modulation is process in communication system which is simplified many issues for modern communication for several reasons. Most important is that efficient transmission. Modulation allows signal to travel longer distance with minimal loss of quality. Similarly, modulation also provides frequency shifting. It shifts low frequency baseband signal to higher frequency and making them suitable for transmission over antenna and cables. Similarly, multiplexing by modulating multiple signal on to different carriers, they can be transmitted simultaneously over the same channel. And another important is noise reduction, which is the most important properties of modulation. High frequency signal are less susceptible to noise and interference compared to low frequency signal. In modulation, we offer high frequency signal to the channel. So we can say that modulation enables the reliable, efficient, and clear transmission of signal such as voice, video, and data over communication channel. Without modulation, modern communication system would be impractical. Baseband refers to the band of frequencies that represent the original source of information. The baseband signal, also known as message signal, typically has a lower frequency and contain the data or information to be transmitted, such as audio or video signal. In communication system, the frequency of the carrier signal is usually much greater than the baseband signal. The carrier acts as a vehicle to efficiently transmit the message signal over a long distance communication. The process of modulation involves varying one or more characteristic of high frequency carrier signal such as amplitude, frequency or phase in accordance with the baseband signal. The signal produced as a result of this process is called the modulated signal. This modulated signal is suitable for transmission over a communication channel as it overcomes the limitation of baseband transmission such as range, noise, and interferences. This block diagram illustrates the modulation process in little detail, especially observed in communication system. It shows the interaction between three key components: the message signal, the carrier signal, and the resulting modulated signal. Message signal, which is called baseband signal. The message signal contains the actual information or data to be transmitted, such as audio, video, or data signal. It is typically a low frequency signal that cannot be transmitted efficiently over a long distance due to energy losses and noise susceptibility. Carrier signal. Carrier signal is a high frequency sine wave or cosine wave that serves as a vehicle for carrying the message signal. The carrier signal does not contain any information by itself, but it helps in transmitting the message signal efficiently. The characteristic of carrier signal such as amplitude, frequency or phase are varied during the modulation process to embed the message signal. Modulation process Modulation process combines the message signal and the carrier signal. The purpose of modulation is to shift the frequency of message signal to a higher frequency for efficient transmission over a long distances. Depending on which the property of the carrier is varied, the modulation can be different types. It may be amplitude modulation, varies the carrier amplitude. Frequency modulation varies the frequency, carrier's frequency, and in phase modulation varies the carrier phase. Now we discuss about modulated signal. The modulated signal is the output of the modulation process. The signal combines the high frequency carrier with the message signal information. The modulated signal can be efficiently transmitted over a long distance through communication channel such as radio wave, optical fiber, or coaxial cable. At the receiver end, the modulation process is reversed to extract the original message. Modulation is the core concept in communication system and it has many benefits that have made modern connectivity seamless, efficient and highly reliable. Let's explore how modulation impacts our life through its remarkable features. Long distance communication, one of the primary advantage of modulation is enabling long distance communication. Without it, signals such as your voice or data would lose strength and degrade over distance. Modulation helps by superimposing low frequency signal onto high frequency carrier wave. These high frequency signals can travel together distance with minimal attenuation. Whether it's a radio broadcasting, satellite communication, or mobile networks, modulation ensures that signal retain their quality and reach their destination, connecting people across the globe. Another important advantage is efficient spectrum utilization. The radio frequency is limited, yet it is the backbone of all wireless communication. Modulation techniques allow efficient utilization of this resource by allocating different frequencies to different signals. It ensures multiple signals can coexist within or without interferences. For instance, in cellular network, multiple users share the same frequency bandwidth without affecting each other's communication. This efficient spectrum management has made large-scale communication systems like 4G, 5G, and Wi-Fi possible. Similarly, another advantage is a smaller antenna size. Do you know that the size of the antenna is directly depends on the frequency of the signal? Modulation enables the use of high frequency carrier wave which correspond to smaller wavelength and this allows us to design compact antenna that are both practical and portable. Think of the antenna in your smartphone, radio, or GPS devices. They are tiny yet highly effective. Modulation makes this miniaturization possible, enhancing the functionality and aesthetic sense of modern communication devices. Another important is improved quality signal. Modulation also improves the quality of the transmission signal. Techniques like frequency modulation and phase modulation are particularly resistant to noise and interference, ensuring clear communication even in challenging environments. Advanced methods like quadrature amplitude modulation or COM increases data transmission rates without compromising the signal clarity. Whether you are listening to crystal clear frequency modulation radio or streaming a video online games, modulation ensures a seamless experience. Multiplexing capability, another incredible benefit of modulation is its ability to support multiple signal to be transmitted simultaneously over the same channel. For example, in television broadcasting, different channels are transmitting on different frequencies using frequency modulation multiplexing FDM. Similarly, in digital communication, modulation technique like OFDM, orthogonal frequency division multiplexing, divide signals into subcarriers to enhance data transmission rates as well as reduce interferences. Another important of modulation is wireless communication. Wireless communication relies heavily on modulation to enable high data rates and reliable connectivity. Techniques like Wi-Fi, Bluetooth, and 5G network use sophisticated modulation technique to enhance performances. Without modulation, we would not have the fast wireless internet or seamless mobile communication that we are enjoying today. Now, another important is digital data transmission. Finally, modulation has paved the way for transmitting digital data. In today's world, most communication system deals with binary data, either ones or zero. Modulation techniques such as pulse code modulation, we call it PCM, or phase shift keying PSK, convert digital data into transmittable signals, enabling the internet, video calls, mobile game, and cloud computing to function efficiently.